So in this lecture, we're going to be looking at perpendicular vectors. So this is when two vectors are perpendicular to each other, which means they are at right angles to each other. So let's try and visualize this and explain what is interesting about perpendicular vectors. Okay, well let's first start off looking at this. What is A times B? Well, we worked out with the component form. It's just a simple case of doing A times B equals 2, because that's the first one, times 3, then plus 0 times 0, which is going to be 6. Okay? So what we've done here is we've multiplied the x component of this vector and the x component of this vector, and we get this thing 6. Okay, seems pretty straightforward. So what about this one? Next one, so what is A times B? Well, it's just going to be the same as 4a dot b equals 2 times, well, 2 times the other x1, so it's 2 times 0 plus 0 times 3. So now we've ended up getting a dot product of 0. Okay, this is a little weird. So why do you think we've got this? Well, if we actually draw out these vectors, it becomes a little bit clearer. So I'm going to draw this first vector A, which has a distance of 2 in the x direction. Then I'm going to draw vector B, which has a distance of 3 in the y direction. 3 here. Okay. So, what is going on here? Well, what we're seeing is that these angles, these vectors are actually perpendicular to each other. Okay, so we can call this 2, 0, and that was the other way around actually. Call that this one's 3, 0, and this one is 2, 0. Okay. So we now need to think about why would the dot product of these be 0? Well, when you look at it, you can see that you're looking at this property, which is the I've drawn this the wrong way around. Apologies. So this is that was right actually. So this is 0, 3, not 3, 0. So 2, 0, 3, 0. So you can see that this has a value of 3 in the y direction and a value of 0 in the x direction. This one has a value of 2 in the x direction and a value of 0 in the y direction. So when you multiply this x direction, this x direction with this x direction, they're saying, well, what would they multiply together? What's the boost factor you'd think of? It's going to be nothing because these 2 points have no overlap into, they don't work with each other to move together. Same with the y direction. And also this is going to be true for the other equation, which is obviously a dot b equals a b cos theta. Because it's at right angles, here it's going to be 90 degrees. If you remember from your cos diagram, it starts at 1, goes down, so this is 90 degrees here, so that is going to be 0. So this here would be 0. So your final answer is going to be 0 again. So this is what you need to remember, that perpendicular vectors have a dot product of 0. So I've just gone to explain this point a bit more in the next slide. So yeah, if you've watched the video, you will maybe recognize this before, but it's the same idea. So if you've ever played Mario Kart, you might have remembered these kind of boost pads you get. So you drive across it and then you get a big boost. So when you're thinking about vectors, right? If the Yoshi, I'm pretty sure it's Yoshi, was coming in right at 0 degrees, completely in line with the other vector, which is the boost pad, it would get the maximum boost. It would, if possible. And if it comes in at a slight angle, these is going to get a slightly smaller boost. But if you come on at complete right angles, you're not going to get any boost because this is boosting forward in this direction, and then there's no component of forward direction when you come at this angle. There's nothing to boost it forward by. So That's where it doesn't work. The same logic that if you just landed on the pad, you're moving at 0 miles an hour. So it's just going to stop you. There's nothing to boost forward. So that's another way of thinking vector multiplication is it's one vector boosting the other vector in the direction that they have in common. So this is what you need to remember. It's always 0.